Hello, Michael. I'm not sure if it's my technical problem, but I cannot hear you.
Okay, how's that? Is that better?
No, it's better now.
That's better.
Yeah.
Okay, right.
Okay.
I was just saying to our audience, you're going to be talking today about the RSPro800 X, a remarkable printer, an SLA printer with 4 lasers. I'm going to hand over to you to do that. I'll be back a bit later to do the Q&A. So if the audience have questions, please use the Q&A function to ask those. Do you want to get your slides up as well, so so the audience can see those?
Okay. So I'm not presenting yet.
The slides need to be put up on screen again. Yes, now we're in the live. There we go. Okay. Right, got the slides. Good. I'll hand over to you, and I'll be back in a bit.
Yep. So thank you very much, Michael, for the introduction, and thank you everyone for joining us today. So my name is Hao Yang. I'm a general manager of UnionTech in EMEA. So today we are going to talking about 4 laser system in industrial SA market. This is also the first time that the 4 laser system has been used in SLA 3D printing. And before that, maybe a short introduction about myself. My name is Hao Yang. I've been working in 3D printing industry for around 7 years now. And I worked for several 3D printer manufacturers. And personally, I'm based in Germany, in Stuttgart. And I had an engineering background in my first jobs after my universities. I worked in a few automotive industry companies before I started my journey in 3D printing. So let's look at our agenda today. So it's quite basically quite straightforward. I will be talking about a bit who we are, who is UnionTech, and what we do, and what differentiates us with other manufacturers. And then I will share a little bit the view as industrial SLA manufacturer, how the SLA market has been evolving in the last years, and what is our motivation on working on a multi-laser system. And then we will have a little bit deeper dive into the 4 laser printers that we have just launched in the last Formnext. It's RSPro800 X. And first of all, we will ask a question why the 4 laser system makes sense and why we made it. And then we will see how the printer is working, what is the features and so on. So first of all, a few words about UnionTech. So UnionTech is a company founded in the year 2000. We are also one of the first 3D printer manufacturer in China. We have been focusing on industrial SA basically from the day one. Yeah, globally, we work very closely with more than 60 sales and service partners. And we also have a few regional offices. We have 3 overseas subsidiaries. One is in the US, in Texas. In Europe, our headquarters is right now still in Frankfurt. And in 1 month's time, we are going to move into Stuttgart. And we are building up our new facility right now in Stuttgart with showroom and more importantly, also a demo center. We will showcase the whole workflow. We will do the training. We will also taking some printing tasks from the European region and to keep the printers running there. We have also a facility in Vietnam where we mainly serving our shoe molds customers. Globally, UnionTech has around 7,000 employees. And one number I need to mention a little bit is that we have more than 60% market share in Chinese market, and thanks to the long-standing leadership in the market, and also our UnionTech powerful and reliable product. So till now, we have installed over around 15,000 industrial SLA printers worldwide. So the printer number we counted here are all industrial grade printers, which has the build volume from 250 to 450, 600, 800, and all the way to 2100 millimeter in the X direction. So the majority of the printers installed are, however, in the range of 600 and 800. So this is also the sweet spot of the printer size that we learned by our own experience in scaling up the industrial market. As the industrial is growing and also our install base is growing, the role of UnionTech is also evolving slowly. We have established our own materials development. So it's a little bit extension from a purely hardware manufacturing. This helps us, of course, to close the loop of fast iteration of process development for new applications. And more importantly, UnionTech has become also one of the largest customer and user of our own printers. We are running a huge capacity of SLA printers to providing printing services to different countries and industries. And now we have 4 printing factories across China at this moment, providing professional total production solution for parts to industries like automotive, aerospace, medical, defense, consumer electronics, and so on. And for some specific applications such as investment casting, we have even a dedicated factory to produce parts in an efficient way. Yeah. So here you can see our role as a heavy machine user. I have to say that the printing service sector of UnionTech, as I mentioned, which has a dedicated brand name, UnionFab. UnionFab has become also a very professional parts supplier globally. At UnionFab, you can get instant codes and get the parts delivered very quickly, and the quality and the speed has always been our first priority. Maybe some of you are already a customer of UnionFab. We have all the main technologies, as you can see here, from the SLA to SOS, SLM, FDM, so all kind of technologies. For the SLA parts, here you can see as well that the capacity of the SLA printers are also mainly at 600, 800 bit size. Yeah. So the experience as a heavy machine user is also very valuable for us as a machine manufacturer to make our own product strategy, especially for high efficiency production, which is also our main, I would say, the main segment we would like to target. Yeah, before we get a deep dive into the product itself, maybe I can share some observations and experiences we collected in terms of large format SLA printing. Yeah, this might be useful to demonstrate our view, our roadmap of how to constantly improving the efficiency of the production. If we have a look at the how our customers or how our own printing factories are producing parts, we can see a very clear trend that we are currently in the middle of fundamental shift in how the industry views and uses SLA. It was started with prototyping, as many other 3D printing technologies. And in the prototyping era, the goal was quite straightforward. The customer will ask, of course, does the part look good? Yeah, we care about the surface quality and we care about accuracy. But if it took 20 hours or 30 hours to print, it's fine because it's anyway faster than traditional manufacturing method. But now we see that the question is changing. Yeah? Now we are entering the serious production era, especially for industrial SLA. That is how we see it. In this area, the questions is different. Sorry. And the customer will ask, what is my cost per part? And what is my, for example, weekly output? Or can I integrate this 3D printing into my existing manufacturing workflow? Yeah. So to be successful here, I think SLA needs to go beyond just quality, but also start focusing on the industrialization. Yeah, that means we need to stabilize, we need a stable process that will be compared also sometimes with classical manufacturing methods. Yeah, for example, injection molding. Some customer will compare the parts from the SLA printers directly with injection molded parts, for example. Yeah. And the productivity for larger batches will be also investigated to justify the investment. Yeah, because at the end of the day, the additive manufacturing is just a manufacturing method, and the end users cares just about their productivity. Due to the relatively reliable process of SLA, we see our customer have gone also the way from prototyping to serial production very quickly. And we see more and more such examples, like application like jigs and fixtures from some automotive customers in investment casting and molds making, either for shoe molds or tire molds. And yeah, interestingly, many of them are in so-called hybrid manufacturing environments. So basically, the 3D printing is just one step of the whole manufacturing process and being fully integrated into the existing serial production workflow. Yeah. In these cases, the 3D printed parts are even not final parts or end-use parts. They will be used for the next process or even being destroyed. But I think it doesn't matter, in my opinion. In the opposite, it helps the 3D printing at the end of the day to be part of the serial production. So that is also happening every day at our customer sites. As you can see, the keywords here is scale. We believe on SLA, and still I think SLA has a great potential in driving additive manufacturing into serial production. The pictures here are from our customers. I think especially in the Chinese markets, many of our customers are already running more than 100 printers for their applications. So under the challenges of driving the output or improving the efficiency, basically we have to ask questions here, how to have, let's say, a higher throughput. Yeah? What is a strategy? Just to keep it complete, here are a few ways we, let's say, are working with our customers on the daily basis on the strategies how we can improve it. Yeah. First of all, of course, increasing the speed. Yeah, basically, we need to push the physical limit of the scanning speed, of the laser power, of the hardware. Yeah. So this is a natural way that we will constantly working on. And of course, also how to increase the output per build. The main question here is how we can get as many good parts as possible in one printing job, and which size of the platform is most efficient. The platform should not to be too big, as we cannot always guarantee to cover the whole build platform with parts, especially in small batch printing. And the platform should also be not too small either, as there will be too many interruptions between the batches, taking off the parts and start the prints again. So yeah, in addition, I think we always hope that we can print parts, especially the larger parts, as one piece, and to avoid assembly work afterwards, and which is normally very time consuming. So, and also most of the time has a negative effect on the parts quality. And post-processing, of course, is also very important here, that if you don't automate it, it will cost a lot of time, and yeah, in the end, it's not very good to the efficiency. And we should also not forget about materials as well. Yeah, as resin has its certain chemical limitation, it cannot be cured at any power or at any speed. So certain optimization towards the printing speed that make this more suitable for fast printing is always helpful. Yeah. Of course, to have a higher throughput, we can always add more printers. This is a simple way of thinking, but I think you can imagine in many cases, this is also the last option the customer will take. Yeah. So the utilization of the printer is also a very key factor here. Any downtime of the printer affects negatively to the output. So here's also the maintenance strategy important. And last but not least, the production-oriented workflow has to also be taken into consideration as well. Yeah, if you manage the printer fleet in a way that how the state-of-art factory has been managed, you will see the difference on the productivity. Yeah, we can see basically based on our own experience, a proper MES system is very important. It can not just improve your efficiency, but will also reduce the labor cost, for example, which is needed to operate the printers. So this is basically how we see the strategies of improving the throughput of a printing factory. But at the end of the day, as a machine manufacturer, we are still, let's say, putting serious efforts on continuously working on faster systems, yeah, together with all the other strategies here listed. So let's then have a deeper look at our 4-laser system and why we build it and how we build it. Good. So here you can see our flagship printer of the build size 800, which is RSPro800 2.0. This printer has been launched for a few years. It's a very reliable machine, very powerful machine, and we installed quite a lot in the last few years. And here's a new printer from us, the RSPro800 X. which was launched last year at Formnext in Frankfurt. Yeah, this is a printer that we are going to talking about. Basically, this is our new development, especially targeting the manufacturing scenarios where the maximum output is required. So both of the printers will stay in our portfolio and will be available in the future. So basically, the 800X here is not replacing the 800 2.0. Yeah. So as you can see here as well, the 800X has a totally new mechanical design, which we will have a deeper look later as well. So to answer the question why, yeah, I think we have to have a deeper look at the printing time here, yeah, because the printing time, as you can see, is basically there are two different kinds of time. Yeah, we need to understand. So one is basically the laser scanning time. Yeah, the other one is the time that's between each laser scanning. It's a so-called recoating. So basically, the recoater will move from one side to another to prepare the layer, so that is ready for the next layer scanning. So what a multi-laser concept could essentially influence is only the time for scanning, right? So how much time the printer will spend on scanning will basically determine how much time saving we can have here. So how high the potential is there. Yeah. So at this percentage depends basically on the density of the parts on the platform. It's also quite easy to understand, I think, whether the printer needs to scan one part or it need to scan 100 parts. The scanning time for each layer will be totally different. So, but the recoating time stays always the same. So this is also the recoating time. Some people call it recoating tax. The recoating tax is will be becoming lower when the packing density is high. So basically, on the diagram on the right side, you can see a rough relation of recoating tax and platform packing density. At a very low density level, like the 10% on the very left side, the recoating time occupied around 70% of the total printing time. But when the density goes up beyond 50%, the percentage of scanning time goes up to nearly 70%. Now the reduced scanning time becomes more significant and will have direct impact on the total printing speed. Yeah, here we can have a look at a concrete case where the density level is around 60%. And at this time, the scanning consumes about 70% of the total printing time. In a simplified calculation here, we can see a dual laser system basically can finish the scanning at half the time, and a 4 laser system can further reduce the scanning time by half. So it's basically in total more than 50%, so 52.5% time saving compared to a single laser system. So in this case, the potential of time saving for scanning has been, I would say, largely utilized. As you can see in the diagram in the middle, the scanning consumes right now only around 37% of the total printing time. Yeah, so further speed up of scanning does not really bring much efficiency gain anymore. Yeah. So here are two printing jobs as examples. Yeah, that's what we tested on our RSPro800 X. So the first one is with relatively lower density. Yeah, but it can certainly happen in our day-to-day operation. Here we would say the saving around 70% of the total printing time. And for the below examples, where the density is relatively higher, the efficiency gain will be more than 40%. This density is also more the, I would say more for the serial production. Yeah. In our tests, for different kind of printing jobs, the average saving of time of a high density prints will be in the range of 40 to 60%. Yeah, people may ask, well, it's so hard to improve the speed by 30-40%. Yeah, because now we are talking about 4 laser system instead of 1. How about optimize a single laser system? Yeah, how much potential do we still have here? I have to say, of course, the optimization of the single laser system has never stopped. However, the ways of optimization has more or less already reached its limit, such as improving the power of laser. Yeah, it's nice, but it will also affect the resin negatively. Yeah, by overcuring, and also in longer time, the resin will degrade more faster. And the scanning speeds, we can also not increase too much because the resin also has its chemical limitation. The variable beam has been actually a very useful way to effectively improve the productivity, but it also works well for certain or for many geometry, but also less well for the others. Yeah, especially if the parts are with a lot of details or thin walls, where mainly smaller or constant laser spots being used. So in those situations, I would say, yeah, probably the parallelization helps more. Yeah, I mean, multi-laser concept will be more efficient in this way, in these cases. Yeah. Having said that, I think in order to unlock the fully potential of productivity as much as possible, the optimization and the parallelization will be, to some extent, a very necessary measure. Yeah. So we have been talking about the productivity all the time, but the multi-laser concept will also offer some other advantages, which we cannot get from a single laser system. So in the case, for example, of redundancy, the multi-laser system can continue to print in the events of one laser fails. Yeah, if one laser is waiting for maintenance or replacement, the printer can still work with less amount of lasers. This is possible. It will give the printer, the maximum uptime and also the more flexibility on the maintenance plan. And of course, for the multi-laser system, the heat can be distributed in a more balanced way, because the laser can move from different direction, and it will, have also positive result on the parts quality. Yeah. Sorry. Sorry, it's still ongoing, Michael? Sorry, I see that my
slides for a moment. We can still hear you. We can still see you.
You
but
can still hear me? Okay, right, perfect.
Slides have dropped off.
Yeah, I think I need to share again. Sorry, 1 second.
Well, I hope everyone's finding this interesting. I see a few questions coming in already, so we'll be coming to get more insights from Hao for all of the questions you may have. If you want to ask those now, so you can get a better chance of us having a chance to get to those questions, then please do that. You can use the chat, and I'll move the things over to the Q&A section, or you can just ask them directly in the Q&A section. And if you take a look at that section, maybe you'll think that one of those questions is something you'd like to know. There's actually an opportunity to vote those questions up and down in that section as well. So please make use of that. Right, looks like we're back with the slides.
Yeah.
Do you have?
Sorry for the interruption. So my slides suddenly disappeared. So okay, I think we have been talking about the why and what was actually the motivation we will make a 4-laser system, and now we will have a deeper dive into how the system works. Yeah. So firstly, I would like to mention that the 4-laser system, the 4 lasers do not have the fixed zones, so all of them can work on the entire build platform. So this gives us some important advantages. One big advantage is that the stitching problem is avoided, especially for larger parts, because the lasers are not separated, so no stitching lines are visible on the parts. And also the other advantage is the flexibility. Each laser can reach every area of the platform, so the printing speed can be increased no matter where the parts are positioned. So in the end, this system is not basically 4 lasers or four printers in one. It's just 4 lasers working together and can all contribute to speed up of the printing process. On the software side, our engineer has also developed special algorithm to control the laser scanning process. So there are basically 2 main targets here. The first target is that basically all 4 lasers will work at the same time. So ideally, they start together and they finish together. This way, the idle time of each laser is reduced to a minimum, and we can achieve the shortest possible scanning time. The second important topic here is the intelligent task distribution. The system automatically decides which laser scans which area, and also selects the optimal beam size for each laser. This means we do not only print faster, but we also maintain a very good printing quality. A typical example here is one laser is dedicated to scan the outlines, while the other lasers scan the hatching area at the same time. And they can use different beam size and different speeds depending on the task. By doing this, we reduce the total scanning time and allow the lasers to move at optimized and safe scanning speed. And to achieve the redundancy, we can give also the maximum flexibility we can also configure how many lasers will be working together. So either it is 1 or 2 or 3 or 4, but it's most being used in a scenario that that if 1 or 2 lasers is in maintenance mode. Yeah, furthermore, the whole optical system is completely enclosed to prevent from environment contamination. We all know that sometimes the environment is not always as clean as we expect as we work with resin, right? So with this design, we can ensure the maximum hardware reliability and consistency in the printing quality. So on the mechanical side, our engineers also made several important considerations. So basically, the printer is not just more robust, it's also more flexible because as I mentioned, all 4 lasers need to cover the entire build area, which means the distance between the lasers and the build platform had to be increased. So this result in a machine height of about 2.4 meters in normal operation. Yeah, to make it more easier to be transported in a standard container still, and also pass through normal building entrances. The upper part of the machine is designed to can be folded down into a transportation mode. It takes logistic and installation much easier. In addition, as safety feature, we also implemented a very high safety standard. The viewing windows and the doors are equipped with anti-reflective safety glass, which was not the case in all printers in this segment. This protects the operators from laser reflection also during the operation. And furthermore, as we completely redesigned the mechanical structure for the 800X, we also added several comfort features for daily operations. So one example is scraper design. The scraper is very easy to change. It can be removed and installed again with very little effort. So no special tools are needed. Any 2 screws, basically, as you can see here in the picture, has to be removed. Yeah, that's it. This makes, of course, the maintenance and the repair much more efficient. And most importantly, no recalibration is required after changing the scraper. And we also simplified the VAT replacement process, which is which you can imagine that will be a significant change for the operators, especially, because the VAT is usually the largest and heaviest part after the printer is installed. So with this new design, the VAT can be moved easily by any operator using basically one-click mechanism. So just like the scraper, no recalibration is needed after replacing of the VAT. This saves time, reduce the errors, and makes daily operation much efficient, much easier. Okay, just to summarize, I have a small video here for the new 800X. Let's have a quick look. Okay, yeah. So I would say that it's also a very nice printer. Yeah. Okay, so I still have 2 slides. I think I need to also mention a little bit our software just to make it complete, because as I mentioned before, in serial production, it's not just about the printer itself, it's also the whole workflow. And the UT1, yeah, which is our all-in-one software, it combines almost all the functions needed to run a 3D printing factory in one system. This is the software that we developed based on our experience in the last many years, and we launched it, I think, 2 years ago, 1.5 years ago. And many of our especially customer running serial production are using it. Of course, we are also the user of this software every day. UT1 includes the pre-processing and task assignment and automatic printing, yeah, remotely. So in most cases, it only takes a few clicks to start a job, yeah, because all process parameters are already preset, especially for our customer, like they are printing shoe molds continuously, they are printing tire molds continuously, and the job preparation time will be largely reduced by using this software. Yeah. It's a very powerful tool. It helps us to reduce the workload for engineers, but also for operators. Yeah, because in this way we can distribute printing tasks and start the print remotely, and we can have also a better monitoring of the printer status in our printer factories. So many manual steps are in this case are not no longer needed. Yeah. So in the end, by using UT1 as a central management software, a lot of manual intervention, or the basically in general, the manual intervention is kept to a minimum. Yeah. So as we continuously integrating more features into UT1, here I would like to also highlight a few of them. First of all, of course, we also use AI now to automatically identify the parts and place them on the build platform in an optimized way. Yeah. Parts, for example, with similar geometry are grouped together and placed as dense as possible. Yeah, this helps to achieve the better scanning efficiency and also a better printing quality in the end. Yeah. The function is especially quite useful when running a SLA printing or SLA production environment. In this case, a lot of time is usually spending on selecting which part or which printing jobs can be combined. And if you are printing hundreds of parts per day, you will definitely feel the difference. And with UT1, basically a lot of jobs like selecting the parts or combine the jobs or select the printers, which which printer would be, let's say, printing for the next jobs with the right materials. This kind of thing can be automatically done by the software. Yeah. And of course, in addition, we have also further optimized the adaptive support function. The goal here is also quite straightforward, that we would like to achieve higher part stability by using the right support structure, but also the minimum amount of materials. Yeah. So all these features basically significantly reduced manual work, saved a lot of time, and increased productivity in the end. Yeah. Especially when you are running or you are on the way scaling up your SLA production. So I think that's all for my presentation today. So Michael and also our audience, thank you for your attention, and I will be very happy to answer your questions.
Marvelous. Thank you for such an in-depth exploration of a very exciting system, and hopefully something which is going to progress the industry. I particularly liked the insights in how to incorporate this into a much larger production network, which is, I'm sure, where things are going with machines like this. As expected, our audience, as always, have come up with some very insightful questions. Before we get to those, I've got a couple of things I'd like to know a bit more about, if that's okay. You spoke a bit about, well, a lot about the 4-laser sort of setup. Let's just maybe you tell me a bit more about how the system handles those transition zones, with the 4-laser coverage, and particularly how that might work with, say, finer surface detail requirements.
Yeah, the transition zones, you mean the, how to say, the zones between the different scanning areas on the build platform?
Yes, indeed.
Okay, yeah, I think that's also a typical, let's say, question in large format, especially large format SLA printers. But in our case, I think the transition zones, or basically the stitching lines, is no longer an issue, because here we have all the 4 lasers covering the whole build platform. Yeah, so we will not. The software will not use the multiple lasers to scan one outline. Yeah, so the outlines will be normally scanned by one laser, so it is continuously scanning and no interruption, and the parts will also be basically one part, not several parts be stitching together. So different than, let's say, some other printers. I have to say also some other printers in our portfolio has a relatively large size on X direction. Yeah, for example, the 900 machine or 1400 machine, we are using multiple lasers. But in those cases, we cut in the build platform in several zones. Yeah. There we will have more, let's say, issue on the transition. But here we how to say, basically avoid this problem.
So this is some kind of load balancing algorithm that determines where the laser's handed off. Are there any sort of part geometries where that becomes challenging at all?
I think with multiple laser, we have the maximum flexibility. So to answer the challenges of difficult geometry, some geometry which is challenging for typical one laser system, I think it's no longer difficult in 4 laser system, because, as I mentioned, we have the flexibility to distribute tasks to different lasers, and Yeah, and the scanning load is also a little bit distributed. So yeah, and yeah, just one small point for the variable beam size, which is also mainly implemented in the one laser system. We can do it either by, let's say, having variable beam for each single laser, or we distribute the different tasks of the different spot size to different lasers. Yeah, so there we have more flexibility. It also requires, let's say, a more fine tuning in our software control algorithm, I would say.
Let's talk a little about materials. This is a massive part of any serious user's sort of daily experience, right? And I think this question here is quite a good one. I want to talk a bit about the open resin path, but Juan here is asking, are you able to use non-UnionTech materials with this platform?
Yeah, the short answer is yes. Basically, UnionTech machine has always been an open system. So I think I've mentioned shortly in my presentation that UnionTech has also its own materials company. Yeah, we run it as a separate company to do the materials research development. But as we know, many of our customers are also using quite a lot third-party materials. So basically, it's yes, and also it's running very well even with the third-party materials.
Splendid. So are there any sort of differences really in terms of material limitations that are introduced because you have a quad laser system versus a single laser SLA? Are any trade-offs customers should be aware of?
Yes, there are of course challenges for materials as well if we want to increase the printing speed and scanning speed, as I also touched a little bit in my presentation. However, the resin as a chemical product, it also has its chemical limitation. So we can improve the property of the laser and make it more suitable for higher speed printing. As I also mentioned in my presentation, as you can see, the UnionTech resin, which is called TAF127. So this is also the new material that we developed together with the 800X. Yeah, so we want to make sure that we can achieve the maximum printing speed here. Yeah.
Let's ask a bit more about, I think I see where this question's going, but does the recoater move the full distance even if you're not fully packing the build platform? I think the question here is probably thinking about, is this going to sort of, can you print faster, right, if you're not utilizing the full area?
Yeah, yes, they have to move the full distance. Yeah, unfortunately, we cannot save this recoating time even if the platform is not fully packed. Yeah, so that's why we call it text. So it's just no much potential to reduce it.
Another sort of practical question as well. How do you handle the post-processing, given that you've got some sizable parts? Is that something you can help with, or any advice?
Yeah, that's a good question. Yeah, I think we cannot cover all the workflow. As I said, it's one of the workflow is the post-process. I think the washing is a mandatory part of the post-processing for SLA parts. Yes, we together with this 800X, actually, we also developed our own fully automated washing system for the parts. So basically, you just need to take out the parts from the printer and put it in the automatic washing system. It will be washed automatically.
Excellent. So imagine some of the people watching today or watching the replay might be thinking, you know, they've been running sort of a single laser SLA and they may have had experience of it being too slow. What's the most dramatic sort of timeline reduction that you've seen a customer achieve when switching to the RSPro800 X?
Yeah, so we are still testing and fine-tuning our software. Yeah, basically the control algorithm. What we have achieved, as I showed in my example in the presentation, we are now at let's say for high density printing jobs at least reached 40%. Yeah, so it depends on the density of the platform. It will be 50% if we really utilize all the potential of the platform. This will be also one topic in our UT1 software, how we can pack all the parts as much as possible and as reasonable as possible. So it could also drive a little bit more higher speeds. And on the other side, the scanning strategy of the lasers, yeah, because now we have 4 lasers, we can either assign them, 2 of them to scan the contour or the outline, and others scan the hatching area, or we just let one to scan the outline. So it's also a little bit depends on the parts, and also each layer has different scanning tools, scanning routes for the lasers. So I think there's also some potential to how to say, balance the loading or the tasks furthermore. And I think we will see a little bit more higher efficiency. Yeah.
Splendid. Well, we've reached the end of our time today, but how can be contacted with further questions on this or any UnionTech products? So thank you again for joining us today, to the audience, and Hao, thank you for your insights.
Yeah, thank you very much as well. And yeah, if there's any questions I cannot answer today, please feel free to reach out to UnionTech, and we will be very happy to get back to you.
Splendid. Everyone, enjoy the rest of your day. Thank you.
Thank you very much.